We're going to do a problem now in which we're going to apply a few reactions that we have seen already in alkene. So hydrohalogenation, and also we're going to be doing hydration. And so let's see what is the sequence. You're given a problem with a sequence of reactions, and you're being asked to predict the product. So here's what I have. And the sequence of reagents is the following. It says first, you treat it with hydrochloric acid. Then in the second step, you have this. Let's do the more, say, I'm gonna do C3. So this is potassium terbutoxide. And in the third step, we're going to be doing hydrolysis, and then you're going to be doing your oxidation. So we're being asked to predict products here. So let's do that step by step. And so let's see what happens in the first reaction. The first reaction here is the hydrohalogenation of an alkene. And here, well, we will say typically that this reaction proceeds Markovniku. But notice that in the alkene that you have here, the two carbons have the same, say, degree of substitution. So we could have the hydrogen here and have the carbocation here, or the opposite way. So I am going to draw the two possible alkenes, say carbocations, I'm sorry. So if I added the H here, you're going to have the carbocations here. That's one possible. If you did add the H here, then the carbocation is on the other side. And again, why did I do that? Because this carbon right here has the same degree of substitution, that alkene. And so I cannot say one is more substituted than the other to do the Markovniku regiochemistry. So I formed two. However, there is a difference here that is important. This carbocation is secondary. As you see here, the carbon has two substituents. This is also secondary, but this there's something interesting here. Here you have an H. You can do here a 1,2 hydride shift. And when I do that, I am moving the H with the electron. So let's say my final carbocation when I move the H is going to be the following. This is now tertiary. And we know that tertiary carbocations are more stable than secondary. So this is going to be likely the carbocation that is going to lead to the main product, more because it's more stable than that. So after the first step, you form this carbocation, and you will have the nucleophilic attack by chloride. So your final product here of step 1 will be the following after the nucleophilic attack. So because we need space for the second reaction, I am going to draw, say, for step 1, I'm going to be summarizing here. So I'm going to say the product of step 1 is this one, so I'm going to rewrite it. All right? So again, you form the carbocation. You could have made it both ways. This will lead to a minor product. So having that substitution. This one is major because this carbocation you can rearrange by a 1,2 hydride shift. So we get that will be your major product. So, and I'll be working with that. So summarizing, that first reaction gave me the compound that you have there. Now I'm going to work with the second reaction. So what we have here, we need to analyze the reagent. And I'm going to redraw the structure of that. So what is this? This is potassium terbutoxide, which you can draw this way. Yep, that's your potassium, your counter ion. What this is 3 metal groups. So this is really bulky, big base. So in what is this doing is the reaction on the second step is an elimination. Because it is a bulky base, you're going to be doing an E2, but the major product here is going to be the Hoffman alkene. So, and let's say how you know that here. This is your alpha carbon, where your leaving group is. You have next to that one beta position here, one beta position here, and another here. So you will have to remember how is this. If you do the elimination with one of the hydrogens here or here in the cyclic structure, you will get this alkane. So either to that side or that side is the same. That is a more substituted alkene. That's your side-step product. But to get that, you need to use a smaller base. So, for example, it's oxide, methoxide, hydroxide. But here we're using a bulky base. So we're using potassium tributoxide. So you're going to be doing the beta elimination with one of the hydrogens here at the metal group. So the product of that step is then the following alkene. That, okay? So that is my Hoffman product. Again, you need to see what are the possible alkenes that you can form, and a bulky base will give you the Hoffman product, so the least substituted alkene. So it's really selected towards those hydrogens that are there. So this is a product after step 2. That's a product after step 1. So the hydrohalogenation is step 2, the elimination. Let's go with a step 3. And this is a hydroboration oxidation, meaning the hydration anti-Markovnikov. So let's keep doing that. Condition 3. This reaction happens how? Remember, this reagent is used to do a hydration. And that hydration happens in anti-Markovnikov fashion, and the H and the OH need to be added to the same side. What is anti-Markovnikov? Say here. So if we're doing an anti-Markovnikov hydration at this point, that means that you will add the H at the more substituted here. So you are adding H and OH across the double bond. So the H here and the OH here. So the product of that reaction would be the following. You're adding OH here, right? Obviously, you added the H here, but I don't have a Carnot center, so I didn't have to use the wedges and dashes. But pay attention, when that happens, we always need to remember that the H and the OH are added to the same side. So this hydration with this condition is anti-Markovnikov and also a zinc addition. So that will be the final product of that sequence. Here we have used, one concept was the hydrohalogenation of an alkene and we analyzed 2 possible carbocations, and the one that led me to the major product was after rearrangement, that carbocation was tertiary, and we did a nucleophilic attack. So we got that alkyl halide. The second step, we did review a couple of possible beta elimination. If you use a small base, remember that the size of the product is favored, but here we're using a bulky base, big base. So the Hoffman product is favored, so I'm gonna do that. So second step, that's my product. Third step, we did an anti-Markovnikov hydration. So here you will add the across the double bond, H and OH. And so you will have H here, OH here. All right, so we're gonna keep doing problems of the same type. This is a multi-step synthesis. So here you can say, you could have a question saying, how do you make say, how do you make this from this? Well, you will do this two steps. Or how you make this from this. So you could have, when we do problems in organic chemistry, we sometimes ask you the product of a reaction, or we could also ask you, how do I synthesize something from a starting material? Okay, we'll be doing more problems of that sort.